So today's topic is standard imaging's complete stereotactic QA solutions. Of course, the gold standard piece of that is our Lucy QA Phantom, but there's more to it than just that. So what does it take to have a safe and effective stereotactic QA program? After all, delivering just a few fractions at high dose rates can be daunting. Precision and accuracy are important, really of the utmost concern as you care for your patients. So we recognize that choosing the products that provide the highest precision and accuracy for QA should be chosen carefully. And like I just said, the gold standard for stereotactic QA is the Lucy Phantom, which is certainly a very important part of your QA solution, but it isn't the only thing that you need for a QA program. So I will encompass a range of our products that we will then tailor to ensure that you have the stereotactic QA solution that you need. Stereotactic QA goals include positional accuracy, dose accuracy, and validation of imaging systems. So what are the conditions for small fields? I am borrowing some slides from my dear colleague, Shannon Holmes, who is one of our in-house physicists. So SRS defines small fields as having at least one of these conditions that are noted here: loss of lateral CPE on the beam axis, partial occlusion of the primary photon source by the collimating devices on the beam axis, and the size of the detector is similar or large compared to the beam dimensions. So when we go through those challenges, physical size issues, we're talking, field sizes 4 to 40 millimeters here. How is your field size defined? Are you using JAWS or full width half max? Decreased output and alignment, a small misalignment equals a large geometric potential miss. So again, those are some of the physical issues. Scatter from the primary collimator and flattening filter is reduced at small fields, but small enough fields also reduce direct beam fluence. Equilibrium conditions that need to be thought of: lateral scattering, a distance equal to or greater than the range of electrons. What are the practical implications of this? You may start losing lateral equilibrium when the beam width is less than 2 times Dmax. Higher energies lose beam plateau sooner. Detector positioning, perturbation, and so on come into play sooner for higher energies. It's important to characterize profiles, not output factors. Detector size and shape. Volume averaging effects may happen here, so need to ask what is the field profile versus the detector spot size. Also, how accurately can you determine beam penumbra? Consistent and accurate position of the detector can impact your measurement, and this is an important consideration when choosing a stereotactic phantom as well. This, how accurately you are positioning your detector. That is where the Lucy 3D QA Phantom features will provide solid benefits to the user. Perturbation of the beam. Fluence is perturbed at the point of measurement, so ask yourself these questions. How large is the air cavity of my ion chamber? For diodes, is there built-in compensation? And how does the response vary with energy? There are published corrections sometimes available. Make sure that you use the detectors must match your published conditions in order to use those. Signal, please keep in mind that for ion chambers, the signal is proportional to collecting volume. Signal to noise ratio becomes more of a concern as signal decreases, and small signals require an appropriately sensitive electrometer. Again, detector plus your electrometer is important, what combination you select there. Signal to noise ratio can be impacted by leakage, proper electrometer warm-up, or triaxial cable effects, both chamber and extension cables in the case of cables. It's important to match signal strength to the proper electrometer range as well. Accuracy. You need to answer questions about the detectors you want to use for small field measurements. Does it have any energy dependence issues? Does it have angular dependence issues? And what are the implications in different orientations? Are there dose rate or dose pulse dependencies? What else is of concern? There are many, leakage, drift, repeatability, resolution. Can the detector be calibrated? You have a lot to consider when it comes to your detector of choice. So what does SI offer you as a way of solutions? We have several here. We have X-rated diodes, as you can see here. They're available in two orientations. The D1H is horizontal, D1V is vertical. D1H is generally used for phantom measurements, and the D1V is used for scanning. Our diodes are unshielded, have a 1 millimeter diameter spot size. Correction factors are available for our diode. There are two publications from 2014 that looked at both measured and calculated factors. Our scintillators, we have the W1 scintillator here shown with our Supermax electrometer. Since it is a dual channel detector, it needs the dual channel electrometer. And we also have our more recent and upgraded version, which is the W2 scintillator, here shown at the bottom with the Max SD. The W2 scintillator offers several improvements over the first generation. We've decreased the electronic noise, which means we now can offer a 1 by 1 millimeter fiber, in addition to the 1 by 3 millimeter fiber, which is available with the W1 and is the only type. It's 1 by 3 millimeter fiber in the W1 only, but due to the built-in features of the Max SD, we can get down to a 1 by 1 millimeter fiber. Let's see, the strength of both the scintillators, of course, W1 and W2, is that they have a KQ of 1. Yay! Water equivalency for MV photons and electrons. Additional benefits, which are great because of many of the things I just noted previously, there's no dose rate or energy dependence to worry about, and there's negligible temperature dependence. And then last but not least, I want to talk about our X-rated A26 chamber, which is built to reference class standards. It's a micropoint chamber. It's built of all low Z materials, so you get a predictable response curve, and its spot size is 4.3 millimeters. So really, it is unlike other micropoint detectors on the market. Again, with that predictable response curve, it's like using a farmer chamber, but a micropoint chamber in your small field. And then, of course, you'll need your electrometer for your SRS QA. I've referred to the Supermax already. You have two excellent options from Standard Imaging. Our Max 4000 Plus, which is here. It's a robust single-channel electrometer. It's really a workhorse that is used worldwide. It's a go-to standard worldwide for users. Our Supermax electrometer is our dual-channel option, which has the excellent features like touchscreen navigation and a 1-minute warm-up time. It's honestly a lot of electrometer for the investment. You can hear some of the ranges of our electrometers. And it's important to note that both of these have a 5-year warranty, which is the best in the business. So now that I've laid the foundation here for the measurement tools in small fields, what type of stereotactic program are you starting? Often that does not start with multiple brain metastases, right? It will generally be starting with the larger tumors in other organs, typically the lung. So the SI solution to get you started with SBRT includes the stereotactic dose verification phantom here, shown with the lung inserts and the QA slab, which has different density materials and target and avoidance structures to scan, plan, treat, and verify against. The respiratory gating platform which is a simplified motion phantom that independently controls the range of motion and the respiratory cycle. You have our Winston-Lutz pointer, and again, I'm showing you the Supermax electrometer. The stereotactic dose verification phantom, or SDVP for short, is versatile and compact, being only 20 by 20 cm. As seen here, there are at least 4 standard configurations for this phantom. There are embedded fiducials within the phantom to be configured, and then they are configured as nonlinear, non-coplanar to create an isocentric volume. Our chamber plug with gold markers embedded in it is useful for localization and fiducial tracking of smaller tumors. The QA slab, as I showed on the previous slab, and then is right here, enables you to do the spot check of your CT densities, air, water, adipose, fat, trabecular, and cortical bone. And it also includes those high-density target and avoidance structures, which are a great test of your treatment planning systems reconstruction capabilities. The SDVP heterogeneity lung insert facilitates Monte Carlo type calculations, something generally only found in much more expensive phantoms. So if you're currently doing SBRT, maybe you're considering adding stereotactic, getting to those multiple metastases brain cases. So when it comes to SRS, the Lucy 3D QA Phantom is definitely the gold standard used for end-to-end testing of the entire stereotactic treatment chain. The precision manufacturing of this phantom allows users to verify cumulative uncertainties of the treatment chain to within 0.1 millimeter accuracy. This is accomplished by using a variety of inserts with precisely known volumes, geometries, and distances for accurate measurement. We work with each customer to tailor the best Lucy package, as in your overall stereotactic QA package, to make sure you have what you need for your particular setup. 1, 2, 3. The Lucy Phantom is uniquely designed to lock the phantom and the inserts in place to facilitate the reproducible setup and measurement of these very tight tolerances. Again, that goes back to and plays into the small detectors. How accurately are you placing your detector in the field? Lucy really is designed to make sure that the collecting volumes at isocenter and measuring where you need to be. So Lucy, again, is put through the same processes as an actual patient, which means that the phantom will be scanned on CT and or MRI to start the treatment chain. It is therefore very important to perform a variety of QA tests on these imaging systems. For CT image QA, we have marker cylinders noted here, irregular volumes, and the CT spot check insert, as well as distortion grid if needed. So the CT densities, again, like for the SDVP, are a great spot check with the air, water, adipose, fat, trabecular, and cortical bone. The CT scan tests may include various scan thicknesses to find the optimal thickness for SRS imaging, spacing, distortion, and phantom orientation. The MR inserts include matching marker cylinders, as you can see up here. These are filled with mineral oil versus the metal BBs in the other. Matching irregular volume inserts, either of these 3 here or the one with the isocentric irregular volume. The markers and the the isocentric irregular volume, of course, can be used on CT and MR. So the marker cylinders with the CT and MR have a known distance of center BB to center BB of 5 millimeters, and they're placed in the phantom's 16 millimeter center cylinder within the phantom. And again, these are known geometries, volumes in our irregular volume inserts. CT and MR inserts are used to perform fusion and verify accuracy of multimodality fusion, either CT to CT or CT to MR. Verify object reconstruction compared to scanned object volume against a known volume. Verify positions of objects, those centroids and those BBs, and distance measurements. And it is worth noting that we use irregular volumes instead of just circles or spheres, as this is the quickest way to see if there are any issues in your image fusion. After all, an arc on a circle is just an arc on a circle. You can also easily use irregular volume inserts for basic auto-contouring or deformable registration tests. Simply rotate the Lucy sphere, which creates a new shape of a known volume to test against. For treatment plan system QA, you can test the following: organ volumes, manual versus auto segmentation, contoured volume versus a standard volume, or DVH isodose volume. Dose models like Monte Carlo conventional pencil beam, and TPS limitations for small fields, and accessories and couch modeling. Here on the left is a plan image where it delivered 4 conformal arcs to an isocentric target, and the right here is a plan on the largest volume of the irregular volume insert. Verification of the treatment is done using film and micropoint ion chambers and or other small detectors. Note that the detector insert is 1 cm thick, therefore the detector you use with the Lucy Phantom has to have an outer diameter of less than 1 cm. So again, our X-Rated A26 and the W2 scintillator or W1 scintillator are ideal solutions for point measurements. One of the unique aspects of our Phantom is that we lock the detector in place so that you never have to worry about an air gap or chamber displacement. The centroid of the collecting volume will be locked at the geometric center of the Lucy Phantom, no matter the orientation or rotation. And again, refer back to the beginning where we talked about, your detector placement and reproducibility of that is hugely important to your stereotactic QA. So here we are showing my personal favorite insert, which is really a kit of inserts. And we call this the Lucy 3D Volumetric Target Dosimetry Kit. It includes our multi-meds insert. And then you verify using film. Here using the spacers that will help you, depending on the number of spacers which are outlined in our user manual, to cross-section each of these targets. And then we have our target and avoidance structure insert. Again, that black here, high contrast bone material against a blue water equivalent material. These are very difficult for the treatment planning system to recreate, so they're fantastic for testing the contouring and volume accuracy, image transfer accuracy, and the limitations of your dose algorithms. So you can really go through the entire workflow with these inserts as a great end-to-end test. Here we have an image of the C-shaped target planned for delivery, which is then verified with film and micropoint detector. And then the multi-meds insert here, this is an image of that. In this case, there were 4 targets. Again, the multi-meds insert has 4 targets in nonlinear, non-coplanar arrangement. These 4, plus the hidden target insert, which automatically comes with the Lucy Phantom, provides you with 5 targets for planning and treatment. And again, in this case, we're showing just 2 of those targets using the multi-meds insert, the planned versus measured. QA results were found to have a pass rate of 2% and within 2 millimeters and greater than 99 dose agreement in this case. So that's what those images look like. So other end-to-end tests with Lucy include the hidden target test using the insert, the central fiducial. Let's right here. We provide a brass one so that we're MR safe with the Lucy Phantom. All components that are provided with it are MR safe. That's why we use mineral oil filled versus metal in the marker cylinders, for example. But you use the hidden target, or you can use the Winston-Lutz pointer, which attaches in the same place where you would attach the Lucy sphere to the standard precision leveling base. And you want to use the scan, plan, treat, and verify for process QA, checking position, tolerance under 1 millimeter, dose, tolerance under 2%, and a dose distribution. Likely your tolerances are 2%, 2 millimeters, with over 95% agreement. Mechanical accuracy, of course, is tested using the Winston-Lutz pointer as well. And for those of you still using manual methods for your Winston-Lutz tests, you can certainly use our PIPS Pro software to automate that for you and get your 3D offsets. To summarize, really, whether you use the Lucy on its standard precision leveling base, locked to the couch, or you use an interface, you can be sure that you're positioning and repositioning the Phantom accurately, reproducibly every time. And again, locking in your detector of choice, make sure, again, that you can have the highest confidence when you're performing your stereotactic QA. Now, I've focused mainly on Phantom so far and your detectors, but I'm sure you're wondering, other than film, what do we do for patient QA? And in this case, I'd like to bring your attention to 2 of our software programs that really offer you excellence in this arena. One of them is our Adaptivo, which has the pretreatment in vivo and adaptive modules. And the other is LinacView, which is standard imaging's log file-based patient plan QA solution. An overview of the workflow is shown here. An approved plan is exported to both the Linac, including Elekta's MR Linac Unity and LinacView. Once LinacView has received the RT plan, the log files that are generated from each delivery of this plan will automatically be brought into LinacView associated with the original RT plan and analyzed. It's important to note that both Adaptivo and LinacView are continuously running in the background, listening or looking, if you will, for those RT records that they'll pull across and analyze. So not only does LinacView provide pass alert failure results before the patient leaves the table, it also provides a wealth of information to investigate, understand, and address any issues with the patient treatment. Now, to really get to the end of the presentation today, I have to say welcome to the family. As hopefully most of you know, but if you don't, IMT has joined the SI family. I'm showing the Max EA and the Max HD here, being just 2 of the examples of the great Phantoms that are now part of the SRS Phantom family. Next week, my colleague Umar will be presenting on the IMT Phantom. I'm not sure if it's the Max EA or the Max HD, so check our website to find out and make sure that you're registered to learn more. And we have several recorded webinars already about various IMT Phantoms, which you can also go to our website and see. So again, if you have any questions, now's the time to go ahead and put those in. And while you're doing that, before I check to see if there's anything there, I just want to remind you that we, again, have a wealth of information about our products and services on our website. If you think of any questions after I end the presentation today, of course, feel free to contact us, either our sales team at sales@standardimaging.com, or you can reach me at azens@standardimaging.com. We're happy to go into anything in more detail that you may want to on an individual webinar, or you can just ask questions via email or call. That's just fine. And lastly, don't want you to forget that we have our weekly podcast, Out of Gray. So many of you have already listened to those and have signed up to be notified when the next one comes out. Make sure that you're taking a look or taking here, and some of them we're adding more video as well, podcasts. So we have more of them that you can actually see and watch as we move forward this year. So with that, I just want to take a quick peek to see if any questions have come through. We have different QA devices for SRS Brain, such as EPID Imager or SRS Map Check, but when we have multi-mets, the situation for these devices are complicated. I wonder if your device can handle QA for multi-mets SRS Brain. So the Lucy Phantom, definitely, you use, again, like I said, the multi-mets target insert, and then you can use film to verify each of those targets. The new to our family, IMT Phantoms also have, the Max-EA also has a multi-mets Winston Lutz target insert. Again, it uses a combination of film with those target inserts. But that's generally, it is, scan, plan, treat to those targets, and then verify with film how well you hit those targets.